In chapter 4, we learn about the Pythagorean quotients and reciprocal properties of the trigonometric functions. Nevertheless, we also learn how to prove if a statement is the identity. Each of the properties that we have learned in chapter 4, it involves functions of one argument. In this chapter, we are going to learn properties in which functions of different arguments appear. These properties then allow us to analyze more complicated periodic functions that are sums or product of sinusoids. Take for example, cosine of 15 degree. If we put it on our calculator, we'll get that the value is equal to 0.966. Now cosine of 15 degree can also be put as cosine of 45 minus with 30. As we know that 45 minus with 30 will be equal to 15 degrees, so the result could be same. But if I put it this way, cosine 45 degree, is it, so this is a question mark on top of the equal sign, is it equal to cos of 45 minus with cos of 30? So let's try to have it. Cosine of 45 degree, that will be equal to half square root of 2, and then minus with cos 30 degree, which is half square root of 3. Apparently, if we try to subtract half square root of 2 minus half square root of 3, we'll get a number approximate as negative 0.159. Not only the value is different, but also the sign is different. So you can see over here, if I put it again side by side, we have cosine 15 degree is equal with 0.999, while for cosine of 45 minus cosine of 30 degree is equal to negative 0.159. So to answer this question, is it equal to have cosine of 45 degree minus 45 minus 30 equal to this one? The answer is no, it's not a distributive property. So I put this equal with the red sign just to remind us that don't ever put it this way. Don't ever put it on the distributive property like this. But what is cosine of 45 minus 30 degree is? Can we express it on the other arguments? Yes, it could be cosine of 45, cosine of 30, and then plus with sine of 45, sine of 30. And we are interested to understand this more if we have, let's say, a minus b instead of a value. So that will be cos of a cos b plus with sine a sine b. The next question is to answer this. How we can have cosine a minus b in parentheses is equal to cosine a cos b plus sine a sine b. This is called composite argument, and this is what we are going to prove. So we are trying to prove this one, cos a minus b equal with cos a cos b plus sine a sine b. Let's begin with a graphic of Cartesian coordinate, and it has the axis of u and v. And we have a terminal side over here. The angle is a, let's put it this way, and the radius is 1. So we have this, the radius is 1. What will be the coordinate? What I mean with the coordinate is this. What is the coordinate of x and then y over here if we have that the hypotenuse is equal to 1? So in that case, we can have, like, let's say if we put cos A will be equal to the x, the adjacent of this reference triangle, to the hypotenuse, which is equal to 1. So that will be equal to x over 1. Okay, and the same thing, if I put sine A, that will be the opposite length, okay, divided by the hypotenuse length, which is 1, so y over 1. So we can say clearly that the x is equal to cos A, while the y is equal to sine A. Allow me to change it into b instead of a, because later we are going to prove cos A minus b. And let's say we have the next line, which is a, and as you can see over here, I can do the same thing. I'll get that for the x and the y, for this coordinate, I forgot to tell you that this is a circle, so the radius is also 1 for the terminal side of the green line over here. Yeah. So I can put the coordinate as this. This will be equal to cos A comma sine A, while the other one over here, this will be cos B. Let me change the color. Cos B comma sine B. If I want to find the distance between these 2 points, which I call as, let's say, D, okay, so D is the distance or the length of this hypotenuse, then what I need to do is to find the height and then the base, and then use the Pythagorean formula, or what we know as the distance formula. So I need to find the delta y. I need also to find the delta x over here, and then after we have the delta y and delta x, we can put it into the Pythagorean formula. So again, this is what we know as the distance formula. So d square equal with, consider that this is x2 and y2, while cos A and sin A is x1 and y1. So we'll have d square is equal to y2 minus y1 square plus with x2 minus with x1 square. And then we'll have over here y2 is sin B minus with sin A square plus with cos B, okay, x2 is cos B, and then subtract with cos A square. And then let's expand it, okay, without the parentheses. We'll have sin square B minus 2 sin A sin B plus with sin square A, while for cos B minus cos A square, that will be equal to cos square B minus 2 cos A cos B, and then added with cos square A. Now we notice that sin square B with added with cos square B, so I'm sorry, I forgot to put additions over here, added with this, and we added, we'll get from the Pythagorean properties, it's equal to 1. Same also with sin square A with cos square A, that's also equal to 1. So 1 plus with 1, that will be equal to 2. 2 minus 2 sin A sin B minus with 2 cos A cos B. This is our first equation to prove that cos A minus B equal with cos A cos B plus sin A sin B. Okay, so let's keep these equations and let's move to the second figure. So the second figure, I redraw again over here. This is still same. This is angle B, and then this is angle A, and then this is the D. And if I want to find this angle, which is A minus B, right? If I have that this angle is A, this angle is B, then the difference between that will be A minus B over here. Now if I have this triangle, so let's put it O and then B and then A. So if I have this triangle OBA and I rotate it on the origin points as the pivot and put the A over here on the horizontal axis, then it will be like this. Okay, so this happened after I rotate it to the origin points, which is this O. Yeah. Well, the O is still same because this is the pivot point. B, it moves to this one, this place, B accents, we can say it, and then this is A now. This is still same. This will be A minus B. I'm going to erase the first triangle, this one, okay? But notice that this triangle and this triangle has the same shape and size. Now we have over here, this is the A minus B. Again, I can also put the coordinates. Since the hypotenuse, the radius is equal to 1, then I can put the coordinate for this point will be 1, 0. yeah, 1 comma 0. And then for this point over here, it will be I'll put it cos a minus b comma sine a minus b. So same like what we did before on the first triangle. Yeah, when we have it, let me show you. When we have this one, okay, so it's same. Now same by what we have over here, cos a minus b comma sine a minus b, if the radius is equal to 1. And let's find the d again. Okay, let's find the d. So the d, same like before, it will be, let's treat that this is a x2 y2 and then this is x1 y1, and we'll have d square, put it over here, d square equal to 0 minus with sine a minus b square. Okay, so we have this, and plus with 1 minus cos a minus b square by the distance formula. And let's try to have it. We have negative sine a minus b square, so treat that this is one term, that will be sine square a minus b, yeah, plus with 1 minus with 2 cos a minus b, and then plus with cos square a minus b. So this is how we obtain it. And then after that, let's try to expand it a bit. Is there something that we can expand it over here? Yes, or make it more simple. Look, we have sine square a minus b, we have also cos square a minus b. So treat that this is one term, this is one term. It's like cos sine square x plus with cos square x, that will be equal to 1. So 1 plus 1, that will be d square equal with 2 minus 2 cos a minus b. This is the second equations. Now let's bring all this together. Yeah, so we have, from the first statement, we get d square equal to 2 minus 2 cos a cos b, and then minus with 2 sine a sine b, sine b. Okay, let me show you again. This is what we have over here. Yeah, so I put it again over here, and then since the d is same, doesn't change, then I can substitute d square with d square, and then I'll get 2 minus 2 cos a cos b minus 2 sine a sine b equal to 2 minus 2 cos a minus b. I can by the algebraic properties, you can subtract both sides by 2 and then divide both sides by negative 2, and then we'll get cos a cos b added with sine a sine b equal with cos a minus b. This is the mother of all trigonometric functions that we are going to learn in this chapter, but this is the beginning.